Hello, this is Farshid with another video just for you. Today I'm going to talk about home air conditioners. First, we're going to take a look at a simplified layout, and more specifically, we're going to look at cooling only for right now. So looking at a simple AC, residential AC, we have our major components, which is a condenser, air handler, and a thermostat. So the condenser sits outside of the house, outside of the conditioned space, and sometimes it's referred to the outdoor unit. Its job is to recirculate the refrigerant in order to capture the heat that is inside of our home, our conditioned space, and bring that heat outside and release it outside of the house. So again, we have our condenser that is pumping refrigerant to what's referred to as an air handler, our indoor unit. Our indoor unit has couple of other components attached to it. One that's here referred to as the return plenum, and this side we have our supply plenum. Notice the airflow direction. We're going from right to left, warm to cool. Back to the plenum. Plenum, all it is, it's a box that is insulated and allows for the duct system that is in the house to connect to it. In this side, we have either one or two air ducts that they are connected. What is an air duct? Air duct, all it is, it's a tube that carries the air throughout the house. So in this side, again, it's our plenum for the return side. This side brings in the warm air from the house. Then we'll take a look at the inside of the air handler in a few seconds here. Then carries that air, and inside the air handler, with the use of refrigerant, we cool that air. Basically, we take the heat out of that air, make that air feel cooler, then we release it back into the house through our supply plenum, which has number of air ducts attached to it, that these air ducts will terminate in various rooms in the house. So you have an air duct perhaps in the kitchen, in the living room, in the bedroom, in the bathroom, so on and so forth. Now, what controls the whole thing is our desired temperature for our house, for our conditioned space, versus what is the actual temperature of our desired space. So as long as, again, we're talking about cooling, as long as our desired temperature is lower than what the temperature of the house is, our air conditioning system is going to work. Again, we're going to have refrigerant flowing from our condenser, which is sitting outside of our house, bring that refrigerant into our indoor unit, our air handler, use it to grab as much of the warm air as possible and cool it down by contact, and take that refrigerant back to our outdoor unit, our condenser, and release the heat that we have captured inside of our conditioned space, and release that heat to the outside of the house. Okay, so now let's take a closer look of what is actually going on inside of our condenser. So inside of our condenser, we have a compressor, a coil, and a fan. So what happens here is, consider compressor to be similar to a hand pump that we use to pump up bicycle tires. So again, keeping it simple, we have low pressure coming in, high pressure going out, and this high pressure actually is warm, has warm refrigerant in it that circulates through this coil. This coil looks like a radiator of a car. So it has a copper or perhaps sometimes aluminum tubing that is surrounded by fins to basically allow air to flow through this coil, and with the use of a fan to circulate that air over this coil that has refrigerant in it. By circulating that air, we're cooling that air. So if the air conditioner is working and it's working correctly, if you go outside and our condenser is running, if you put your hand over the condenser, you feel air blowing out of top of the condenser. That air should be warm. That the warmth in the air indicates that we're extracting some of the heat that is inside of the house and releasing it outside of the house where we really don't care. We don't condition the outside of the house. Again, how that happens is through this system here, the subsystem that we have here, which is inside of our condenser. The fan is running and it's pulling air from the sides of our condenser, and this coil is actually wrapped around almost 360 degrees. There's a little gap over here where our electrical components sit, but almost a 360 degree wraparound that pulls this air in. As it's pulling the air in, we're cooling the refrigerant and taking that heat that we've captured from the inside and release it to the outside. Okay, so now let's take a look and see what's on inside of our conditioned space. So inside of our conditioned space, we have these components. Again, this is simplified, and what we have is that air that is flowing from right to left, the warm air that we're pulling in through our plenum, through our return duct, passing through our filter that we have, hits another coil. This one is laid out, it's referred to as an A-frame because it looks like an A laying on its side. There are some that's just a slab, but again, these look very similar to a radiator that's used in the car. So that refrigerant is flowing through this coil now, and it's cool enough that once the air that we're pulling in through our return plenum hits it, it cools down. That air, as it's passing through these fins, it cools down. Now, what causes that airflow is a blower motor / blower wheel assembly that's sitting on this side. It's spinning and it's pulling that air in, pulling the warm air in. The warm air hits the cool surface of the coil, and once it passes through the coil to this side, now the air is cooler because we are now capturing some of that heat through our refrigerant. Capture that heat through our refrigerant, bring it back to our compressor. Compressor increases its pressure and acts as a pump to recirculate that refrigerant through the system again, and the cycle continues. So this is how we're basically removing the heat that we don't want inside of our conditioned space with these components. Again, this is simplified. So now let's take a look at some of the components that fail frequently. I say frequently, I should say more than others. So this fan that's sitting outside, this fan motor, it's what's referred to, the type of the motor is an inexpensive motor, and it's called a PSC, permanent split capacitor motor. Basically what it means is the fan, the motor itself, has a low starting torque. So we need some sort of an assistant to get it started. And what's used in the industry is a capacitor. A capacitor is used to help start this fan motor. Where I'm going with this is that common motor failure for the outside unit is the capacitor. Historically, I've noticed that these caps last anywhere between 4 to 5 years. Now, the cost of the cap, fairly inexpensive. It's anywhere between $10 to $15. But what is costly is the labor that's associated with identifying the cap, having the proper license, having the proper knowledge to identify and replace the cap. Now, in this particular case, this is a dual cap. So inside of one body, I have actually a better illustration here. So inside of that body, we have two capacitors. One that services our fan motor, and another cap that services our compressor. And they're both inside of this body here. And you'll see that the cap of the label will have something such as 35/5 MFD. So that's 35 microfarad for one cap, and then 5 microfarad for the other cap. And then there is a voltage rating for it too, 440 volts AC. Basically means it can handle up to 440 volts AC. Now the cap is labeled on the top, and we'll look at the actual cap in a second, but it's labeled with letters C and the word fan and the word Herm. So the fan is the side of the cap that services the fan motor, and then Herm is the side of the cap that actually services our compressor. So the compressor also requires, the motor requires assistance for it to start. The other component that fails not as frequently as the capacitor, but it's the contactor. One thing that I failed to mention is the way the thermostat controls this system is through low voltage wires, so typically 24 volts AC. That 24 volt AC goes to our air handler, and then once the system starts, air handler then sends 24 volts AC to our condenser to start our compressor and the fan. However, the fan and the compressor are at 240 volts AC. So in order to take that 24 volt AC and allow it to turn on higher voltage components, we have something that's called a contactor. So the low voltage comes in here, one leg of it on this side, one leg of it on this side, and then the 240 volts, one leg comes in here, another leg comes in here, and then on the output side of it is what gets served to our compressor and our fan motor. And for this contactor to work, there is a relay, there's a coil down below here. Again, we'll look at an actual one that upon having 24 volts, this lever here pulls down, and we have a current flowing from this leg to the input side to the output side. This is a one-pole contactor. I drew it as a one-pole because I'm going to show you a one-pole. Basically means that only one leg of the 240 is getting switched. The other leg it's hardwired in. Same thing holds true for our indoor unit. The common motor failure again is a capacitor that helps this blower motor to start, to circulate the air inside. So now let's take a look at these components, and then I'll give you some troubleshooting tips. So first thing we'll look at is, we talked about the capacitor. So here's a capacitor. Basically this one here, it says 35.5 microfarad plus minus 10, and then 440 volt AC. And then these are the legs that we were talking about. There's the fan connection here. I don't know if you can see it or not, but there's one here. It says HERM, and it's one over here. It says C. These multiple connections here basically allow you to connect different wires to it, multiple wires to it. So that's one. And then the single cap is this one here. You notice that it has two sets of terminals. Basically, there's one cap inside of this. This one, it says 25 microfarad plus minus 6%, 440 VAC. So one way to test these is you can have a voltmeter that has what's called the microfarad reading. So with a microfarad reading, you can go between your common leg and one of the other legs. In this particular case, we're going against, let's see what kind of reading we get, and I'll tell you. It says 4.89, so I'm going against the on the fan side. I should be getting 5, but plus minus 10. So this cap is good. And then if I go from the common to this leg here, which is our HERM, which stands for hermetically sealed compressor. Really, that's what it stands for. This one says 34.26. So this capacitor is good. Now, that's the capacitor, and then this is our, last but not least, our contactor. As I drew it up, again, this leg over here is connected. This side over here is actually what's getting switched. So we got 110 coming in here, 110 coming in here. So those are the two legs that are 240 that we have our 24 volt. One leg of it connects here, the other leg connects here. This is a coil that I was talking about. Once the coil is activated by the 24 volts AC, this lever here pulls in like that and allows current to flow from here to here. So one way to check this is, again, these are all done with power off. So one way to check it offline is I can put my voltmeter on ohms, check my continuity, and then I can put my meter here and here. Right now we don't have any continuity, but if I push this lever down, which is the work of our low voltage that pulls this down, now we have continuity throughout through this side here. The only reason these will fail is I've noticed depending on the frequency of how often that the outside unit cycles, the contacts here get pitted. Another thing that I've seen is that ants will get in between the contacts over here. They're not very good conductors, and that prevents the unit from starting up. So that's pretty much this video. Hope you enjoyed it. If you like it, click on like, and also to take a look at other videos for the channel. I have a video for thermostat itself, and then I also have a website for HVAC 2020 that has some tools for HVAC industry. If you like what you see on this channel, subscribe and let me know what you guys like to see, and I'll see if I can put it up there for you. Thanks again for watching.